Hello, welcome back. My name is Anna. I'm a TME for the ASR 9000 product family at MIG Cisco. In the last video, we started to understand how ASR 9000 routers can help build more secure networks. We were introduced to this concept called trust, which is more than just security. We saw how ASR 9000 is a trustworthy platform because trust is built into both the hardware and the software for ASR 9000. We learnt about this concept called secure UDI and trust anchor module, which are building blocks for trust in hardware on the ASR 9000. We saw that iOS XR, which is the software that runs on ASR 9000, is always signed by Cisco to ensure trust in the software, and only signed iOS XR images can come online or boot up on the ASR 9000 routers. Along with this, we also saw that the more traditional security features like MACsec or BGP FlowSpec or control plane policing or firewalls, ACLs, all of these are also supported. All of these and more are supported on the ASR 9000 routers in terms of security features that you can apply to the routing data and control plane. But an important feature of trust is that it should be verifiable. Trust is nothing if you can't guarantee that trust has been maintained. So can we do that? Can we verify trust on the ASR 9000 router? Of course we can, and that is what we'll see in this video. Now, when we consider the life cycle of an ASR 9000, we can identify three key areas where trust becomes very important. One is trust during boot time, trust during the runtime, and trust when the ASR 9000 is in a state of rest. Now we'll see how trust is maintained and how you can verify this trust during these three key phases of the ASR 9000 operation. Starting with trust at boot time. So first we'll understand how trust is maintained at boot time. What happens when you boot up an ASR 9000 device with an iOS XR image? So when it is first powered on, the first set of boot instructions that are loaded is called as the microloader. This does a self-check to verify that it is not being tampered with. Now for us to ensure that it cannot be tampered with, we safely store this microloader in a tamper-proof, write-protected FPGA. And this makes the microloader the root of trust for the Cisco's boot process. And this is what differentiates Cisco's boot process from any normal boot process and makes it a secure boot process. So you would have heard of this term called secure boot. This is what it means. We follow a root of trust which is anchored in hardware, meaning the microloader is stored in a tamper-proof hardware location and it kicks off a chain of trust verification. This is what we'll see in detail now. Now, if the microloader's self-validation is successful, it validates the next step in the secure boot process, which is the ROM-on or the bootloader. Next, the bootloader validates the iOS XR image, and if the iOS XR image is also found to be trustworthy, authentic, untampered with, then and only then the iOS XR image boots up on the ASR 9000 router. At any step in this process, if the microloader or the ROM-on or the iOS XR image itself is found to be tampered with, if it does not successfully pass the validation phase, the boot process will stop and iOS XR will not boot up on the ASR 9000 router. So this way you can be sure that only authentic signed iOS XR images can boot up on the ASR 9000 platform. Now once the ASR 9000 router has come online with iOS XR, at this stage you can verify the hardware identity. Now, ASR 9000's hardware identity can be remotely challenged at any time during its operation once it's online. But you also have a CLI using which you can quickly verify the SUDI certificate of all the different modules on the ASR 9000 after booting it up. This is the CLI that helps you do it. So now we've ensured that trust is maintained at boot time on the ASR 9000 platform. We verified the hardware identity. We verified all the different SUDI certificates of the different modules on the ASR 9000. We've also ensured that iOS XR, only signed iOS XR, has come online on this ASR 9000. Now that the ASR 9000 is online and operational, we still maintain trust during runtime of the iOS XR and the ASR 9000 platform. How? First, we've built iOS XR using security enhanced Linux, which means that it gives you a lot of different security features that ensure that iOS XR stays uncorrupted, or at least is very difficult to corrupt or tamper with iOS XR because of features like write or execute, which makes sure that injected code attacks, which make the kernel crash, cannot happen. We also have this feature called address space randomization, in which critical data is not always stored in the same location in memory. The location is always randomized, which makes it difficult to pinpoint a certain memory location in order to cause a crash or attack the data. Now, in spite of these security enhanced Linux features, let's say that somebody is trying to tamper with your iOS XR image or the binary. Is it still possible for us to catch this? Because we understand that iOS XR will be checked during the boot up time. We just understood the secure boot process. But what if the router is still online, is still operational? Do we wait till the next reboot to understand whether the iOS XR image is still untampered with, or is there any way we can find out during runtime whether the iOS XR code is still safe? Of course there is. So in order to protect the router's binaries from tampering during runtime, we have a feature called Linux Integrity Measurement Architecture. Now, in the case of ASR 9000 routers, it is very common that once it becomes operational, it runs for months, even years without a reboot. During this time, a malicious actor could access the router and try to tamper with a binary during runtime. And if we wait for the router to be rebooted once more, that is too long. So to prevent tampering of binaries during runtime, we have integrated Linux IMA or Integrity Measurement Architecture into iOS XR. It consists of two stages. One is the logging stage and the second is the appraisal stage. Now what happens is Linux IMA checks the integrity of every binary loaded into memory at runtime. Every binary carries a Cisco issued signature. Now the Linux kernel validates the signature using Cisco's public IMA certificate that is stored in the hardware-based Trust Anchor module or TAM. During the measurement mode, the hashes of all the binaries are logged into a secure location. Now how this works is, in the IMA measurement mode or the logging mode, the hashes of all the binaries that have been launched, that is all the processes that are running, are logged into a secure location. During the appraisal mode, the signature is validated and the process is allowed to execute, and this event is also logged with the signature. If the signature validation fails, then the failure is also logged. This way, any accidental or malicious modification of a binary at runtime can be detected and its execution can be prevented. Okay, so we've seen how trust works during boot time and how trust is still maintained during runtime of the ASR 9000 router. But what about when the ASR 9000 has been in use, but now it's offline or it has been shut down? Can you still ensure trust in the ASR 9000 when it is resting or in a state of rest? The answer is yes. Among the many features that help us do this, I'll explain two of them. The first is called as Extended Verification Module. Now EVM is designed in order to prevent offline file tampering. Using EVM, we can detect when files on the router's disk have been modified when the router was in shutdown state. Another feature is called SSD encryption. Data at rest, like the running configuration, can also be safeguarded by encrypting the SSD partially. Now this encryption key is stored in the hardware tamper-proof TAM chip. This makes it very secure. Also, we support app hosting on ASR 9000 and a secure vault is available for the apps to store data securely. So even when the ASR 9000 device, which was once operational, is now offline or powered down, we continue to protect the secrets on it. So far we've seen how trust works during boot, during runtime and during a state of rest. Now, like we first discussed, it is important for trust to be verifiable. So we'll see how we can verify this trust on the ASR 9000 next. The first concept I want to share with you is called the trust dossier. During the boot and runtime of iOS XR, various hash values of all the different binary files, like the BIOS, on the kernel, all of these are measured and stored on the ASR 9000. New features in the iOS XR lets us generate a dossier of these measurements along with some more trust information like the operational status, the inventory, boot and runtime integrity of the ASR 9000. This dossier is also, on top of everything, signed by Cisco to ensure further security. So if you want to check this trust dossier on your ASR 9000, you can use the CLI to do so. Now, once we've collected this trust information in the trust dossier, we need a way to verify the validity of this information. For this, Cisco records and publishes something known as known good values or KGVs for all these various components on the ASR 9000 images that we just collected in the trust dossier. By comparing the trust dossier with the KGV data, we can determine that the integrity of the binaries and the inventory of the ASR 9000 has not been tampered with. Now, although we can do this manually, you can collect the trust dossier and you can verify it against the known good values. In today's age, it becomes very important to automate security. So on ASR 9000, we've also automated trust. This is done using Crosswork Trust Insights. So Trust Insights securely requests and collects a signed evidence dossier from the ASR 9000 devices, and then Trust Insights automatically compares this data that is contained in the dossier against the KGVs from Cisco for the iOS XR image that is in use. Trust Insights also displays a lot more information like inventory reporting with history and also trust visibility for the ASR 9000 device. Now at Cisco, we don't just view security or even trust as just a feature we have to deliver on. Security is a culture at Cisco. It starts from the development lifecycle. We build security and privacy and data protection into the business. We plan for it, we develop it, and we operate this throughout the lifecycle of the ASR 9000, and we also help you monitor this. Security is also built into manufacturing at Cisco because in order to protect against counterfeit devices and ensure integrity in the hardware right from the supply chain. And of course, secure operations has always been a key feature of the ASR 9000 router at Cisco. We've always supported network protection using DDoS and ACLs. And we also support data encryption using MACsec. All ASR 9000 routers are compliant with FIPS 142 requirements. We have a dedicated team that manages security vulnerability information for the ASR 9000, which is called the Cisco PCERT team. Along with this, we also have the Talos Intelligence Group and the Cisco Trust Portal, which continuously help us improve and support security and trust on your ASR 9000 devices. So to sum up everything that we've just seen and understood, security is more than just features on the ASR 9000 device. For us, security means trust. Trust in the hardware and trust in the software. We ensure trust in the hardware using SUDI, using the hardware TAM, using the secure boot process. We ensure iOS XR is secure because it is signed by Cisco and only signed authentic iOS XR images can boot up on the ASR 9000 device. We saw how you can collect trust dossiers and compare them against KGVs or known good values in order to verify this trust information that we continuously collect for you during the runtime of the device. We also understood how iOS XR is built using secure Linux. It uses SafeC. We also have integrated Linux IMA into iOS XR's architecture, and we provide industry-leading security features for data encryption and routing protocol security on your ASR 9000 device. So given all this, I'm sure you believe that we have achieved a new level of trust on the ASR 9000 devices that help you build networks more securely than ever before. If you have any questions on the security and trust features of the ASR 9000 router, please feel free to reach out to your accounts team. If you like the content we're posting here, please consider subscribing. Thank you and see you in another video on this channel. Bye.